Okay, so we're going to try graphing a linear relation. First question they gave us is 1a, and they've written it like y is equal to 3x minus 1. Okay, I'm going to ask you questions as we go through. Now let's see if this looks familiar to you. Y equals, I'm going to color code these, mx plus, and then green will be b. Do you remember m and b at all?
No.
It's okay. Okay, m deals with slope. Slope is like rise over run. It's moving up and over, up and over. We're drawing straight lines. That's what a linear relation is, okay? So m is equal to, they usually call it rise over run, okay? Or slope. Okay. And your b is your y-intercept. Okay. And what that means is if we draw a straight line, wherever this line crosses the y-axis, this is our y, right? So we have our y and our x-axis. Wherever the line crosses that point, that's our b, that's our y-intercept, okay? And then the slope of the line is your m. So let's say we have some line like this. The slope changes. Can I get just the line? Nice. The slope changes depending on what angle it's at. So if it's up like this, it's got a higher rise. And then if it gets flatter, the rise and run gets lower and lower. Does that seem familiar at all?
Yeah.
A little? Okay, good. So I drew this underneath. This is like considered like a parent function. That's what they're going to talk about in grade 11. They're going to talk about parent functions. So this is just letters, right? And these letters all represent things when we go to graph them. Okay? So our m, which is our slope, in this one is going to be the number 3. Okay? That's why I wrote it right underneath, so it'll be easy to see. So our m in this question is 3. Now remember I told you m is rise over run. If you look at it, we got like a line up in between. That what it means is it's like a fraction. Do you know how to turn the number 3 into a fraction?
3 over 1?
Yes, exactly. Good. So that would be 3 over 1. So when I go to draw this, I can put it equal to rise over run as a reference. And it tells me that I need to rise, so go up and down, the number 3. And it's positive, right? We didn't put a negative or anything like that. And I need to run positive 1. So I need to go left to right, 1. Okay. But we need a starting point, because I can do that anywhere on the graph. I need my starting point. My starting point is our b. Our b in this question is negative 1. Okay. Should have used one that had numbers already on it. So I'm going to put it on it. So our reference point is b is negative 1. Okay. So what that means, is our y-intercept. So our line is going to cross this axis at negative 1. So that means I have a starting point. I know the line is going to cross at that point, negative 1. From that starting point, I'm going to try to obey this slope. So they're both positive or they're both negative, and we'll talk about that. Okay, rise over run. So let's go up 3, 1, 2, 3, and run 1. Positive direction 1 would be to the right. So there's our next point. Our next point would be here. Then from that point, I continue the exact same pattern. I go up 1, 2, 3, to the right 1, and I have another point. Okay, so if we take a look, I'm going to draw a line through this. It takes me a bit, the line's a bit slow here. We'll draw a line through it. Yeah, it's not the best line, but that's the idea, right?
Right.
Okay, if you can see. Good. So that's our linear relationship. Now remember I said that it didn't make a difference if it was both plus and both minus? Because I want you to remember see if you remember integer rules at all. When you do a positive, we'll use the division sign because it is divided by a positive, our answer is going to be a positive. That's remind you of anything? A little? Okay. So then a negative divided by a negative is going to give you, do you remember? It's going to give you a positive, okay? So that's a trick. And then a negative divided by a positive is going to give you a negative answer, okay? So with that idea, remember we said that both of these were positive, and that's because they look like they'd be positive. No one's written any negative signs in there. So positive divided by a positive is a positive, right? And remember our original number was positive 3, so that works out fine. If I had positive 3 divided by positive 1, I would have got positive 3. But there's another option. I could have actually divided -3 divided by -1, and a negative divided by a negative is a positive. And that would have given me +3 too. So I'm going to test this theory out. See if I can go down 3 and to the left 1. So from that same starting point, I go down 1, 2, 3, and to the left 1. I'll do it again. I'll go down 1, 2, 3, to the left 1. And it just so happens we're on, now I'm not going to draw it perfect, but it was drawn perfect. These are technically on the same line as the line before. I know it looks like there's a kink there. But these are on the exact same line. So it doesn't matter if we use positive or negatives, we'll still end up on the exact same line. Okay? Does that idea kind of make sense?
Mm-hmm.
Okay, so that's like a kind of like a crash course there on graphing a linear relationship. Okay? Okay, so let's say we have another example. This is called standard form. Okay, so we'll call this example 1C. Standard form is where it's not already set equal to y like in our previous question. Previous question, we already set equal to y, so we could set it up like y equals mx plus b. And that's called slope y-intercept form. This one's called standard form. Okay, it's good that we start to learn these two. Standard form. So in standard form, we can't quite go straight to graphing. What we need to do is we need to get it into the form of y equals mx plus b, which is our slope y-intercept. There we go. So in order to do that, we need to isolate for y. So what I'm going to do is I'm going to keep this guy by itself on the left side to start, and I'm going to move each of these to the other side of the equation. When I move -3 to the other side of the equation, do you know what it becomes?
+3.
That's right. So that's 5y plus 2x equals 0 plus 3, which is just +3. Okay. Again, we want to keep y by itself, so now I'm going to move 2x to the other side. What does that become?
-2x.
Yeah, so we have 5y is equal to, we'll say -2x plus 3. We could have said 3 minus 2x. Both would be the same. Let me show you that.
Oh no, I get it.
You got it? Yeah? Okay. Good. So it doesn't matter what order we put them in, we just have to keep the negative sign with the negative number. Okay. Finally, remember the goal is to isolate just y. Okay. So right now this is 5. Do you know what operation this is?
Multiplication.
Yeah, 5 times y. So if I got to move this 5 away so that y is by itself, what do I have to do?
Divide on the other side.
Yeah. So I divide this by 5. Which numbers do I divide by 5?
-2 and 3.
That's right, we divide everything by 5. We divide one left side, so technically this is the entire left side. I divide it by 5. And I'm going to divide the entire right side, so each of these numbers, by 5. Now, I could set it up where I individually do it, just like I did here. Okay, I set 5 on both of them. Or I could have put them as one big thing under 5. For the sake of what we're doing, I separate them. You're going to see why. Okay? So these 5's cancel each other out. We're left with y equals, which is exactly what we're looking for, -2 over 5x. And this is a fraction, so plus 3 over 5. So what is my m, or my slope?
-2 over 5.
That's right. Okay. And what's my y-intercept?
3 over 5.
3 over 5. It's a fraction. So what that means is, we'll refer to a graph here quickly. 3 over 5 is like 0.6, so I'm going to be like somewhere here, just in between, right? If I zoomed in, you could probably get a very good idea of what I'm talking about. But we're going to be there, 0.6. And then we're going to have a slope of -2 over 5. So I'm going to draw this in disappearing ink, okay? -2. I'd have to go -2 from that spot, so I wouldn't actually be on the lines, and then I go 5 over 1, 2, 3, 4, 5. So I'd have something like this, a line that goes through these. This would be like the slope of that line. Okay? The graphing part we've already practiced. We think we know it okay. This is what I want you to remember. We got to set this equal to y. So the algebra part, we got to move all the numbers over. Okay. In question 3, they want us to determine the line of an equation in y equals mx plus b form. So they want me to write it the way we've been doing the last two. But instead of giving me any graph or anything about a slope or y-intercept, they've given me 2 points. Okay, they give me the point of 0, 8 and another point of 4, 3. Okay, so this is our first coordinate and our second coordinate. These are just points on the line. This is the x value, this is the y. Remember, the x is always first, okay? Now with this information, I can actually solve for stuff. I can solve for slope. There's a formula for slope, or m, right? Because m is equal to, I'll show you all the things it's technically equal to. Rise over run, which is slope, which is equal to, and this is a formula. They say y2 minus y1 divided by x2 minus x1. Remember something like that at all?
No.
Maybe, maybe not. Okay, so this is our first coordinate. Because it's our first one, I'm going to call this x1 and y1. And because this is our second, I'm going to call this x2 and y2. So now I have numbers, an x1 and an x2 to plug in, and a y1 and a y2 to plug in. Once I equate all this, I'll get my m, or my slope of the equation. So when I go to plug these in, y2 is 3, subtract y1 is 8, right? x2 is 4, subtract x1 is 0. So I work this out. 3 minus 8, you know what it is?
5.
Negative 5. Divided by, and 4 subtract 0 is 4. This is it. So that is my m. My m is negative 5 over 4. Okay? They tell me all these funny things it's equal to. That's my m. So the slope of this is 5 over 4. Great. So let's try to put it in that equation again. We had y equals mx plus b. So we know our value of m, so I can replace it in the equation. Y is equal to negative 5 over 4 x plus b. Still don't know what b is. But the y and the x stand for points on the line. In fact, they stand for every point on the line. So what that means is I can plug in either of these points, either the first one or the second one, and solve for my b. And I'm going to show you how we do that, okay? So we'll split this in half so that you can see the example I'm talking about. So split it in half. One of the coordinates they gave us was 0 and 8, right? So that was an x and a y value. And the other coordinate was 4 and 3. That was the x and y value. So I'm going to take what I have in an equation so far, and I'm going to replace them. I'm going to replace the x with the x's. And we're going to replace the y in the equation with either y value. So in this one, we'll work with the 0, 8. 8 goes in for y. We have 8 is equal to negative 5 over 4. Our x is 0 times 0 plus b. B is what we're trying to find. In the other example, it's going to look like this. 3 is equal to, I'm replacing the y here, negative 5 over 4 again. Our x in this one is 4, so times 4 plus b. Okay? Quickly, 0 times negative 5 over 4 is just 0. Okay? So it's going to be 8 is equal to b. That was really easy. It just happened to work out that way. This is more likely what you're going to see. Negative 5 over 4 times 4. That's multiplying fractions. Okay? I don't know if you remember that stuff. But 4 over 1 is a fraction. Okay? And technically we multiply the top by the top and the bottom by the bottom. So the number we get is 3 is equal to negative 5 times 4 is negative 20. 4 times 1 is over 4 plus b. Negative 20 divided by 4 is negative 5 plus b is equal to 3. When I move 5 to the other side, I get 3 plus 5 is b. So b in both instances is 8. Didn't matter which one I plugged in, I still get the right answer. So remember though, what they're looking for is this. They want an equation in this form. So we would have y is equal to negative 5 over 4, that was our m, x plus 8. That was the answer they were actually looking for in the end. Okay? That's what they wanted from this question. So in this one, they want you to solve a point of intersection between two lines. So this is 5a, we'll call it. using algebra. Okay, so in other words, there's two major ones you do here, and substitution is pretty much the main one you need to know throughout the rest of math. This is the major one. Okay, so what they've done is they've given us two equations. They don't want us to graph them like in question number 4. Y equals 3x plus 5, and 2x minus y equals negative 6. They don't want us to graph this. What they want us to do is solve through substitution. So here's my equation 1 and my equation 2. Okay? In equation 1, I'm already set equal to y. I know that y is equal to this value here. Okay? What that means is, in equation 2, I can replace the y with that value because I know y is equal to it, according to this relationship. So I take my equation 2, I put 2x, subtract, and I replace y with 3x plus 5, which is equal to negative 6. Okay? Now technically there's a negative, so I have to apply this negative distributive property into both. I gotta multiply it by both. Okay? Try to keep that one in mind. So we get 2x. So think of it like there's a negative 1 here. What's negative 1 times positive 3x?
3x.
That's going to be negative because it's a positive times a negative. Remember those little rules I wrote before?
Yeah.
Let's see. So this one's going to be negative 3x. And we have negative 1 times 5. That's going to give us a negative times a positive. So that's going to be a negative answer. 1 times 5 is 5. Okay. So we have this. Now I'm going to collect my like terms. I can combine what's a like term. These two are like terms. They both have variables after them. Both of these are constant numbers, so I can combine them. The only problem is they're on other sides of the equation, so I'm going to move it over. I'm going to move the negative 5 over. What's it going to become over there?
Positive 5.
That's right. Negative 6 plus 5. I'll combine these two like terms. 2x minus 3x. What that's going to be?
Negative 1x.
Yes, negative 1x, or just negative x. That's fine. And here we get negative 6 plus 5.
1.
Negative 1. Yep. I got to get rid of the negative because they're technically asking me for just x. What is just x equal to? Well, I can divide both sides by negative 1 or multiply by both sides by negative 1. Either way, what's going to happen is the negatives are going to flip. So we're going to get x is equal to positive 1. So that's only one of the coordinates. If we're looking for a point of intersection, what they're looking for is the coordinate where the two lines cross. So I have the x value of that coordinate. The x value is 1. I got to still find the y value. So what's going to happen is I'm going to take this x value, and it doesn't matter which equation now. I can do it to either of them. In fact, we'll do it to equation 1 just so you can see. I'm going to replace the x in that equation with x. Okay, so I take equation 1 again, or 2, it doesn't matter, but we'll take 1. That equation was y was equal to 3. I'm going to replace x in this equation with the number 1. That's what I had just found. Plus 5. Y is equal to 3 times 1 is 3. Y is equal to 8. So our answers are the point of intersection between these two things. These two lines will cross each other at when x is 1 and y is 8 on the graph. That's where the two lines would intersect each other. Okay, let's use. Okay, in question 4, so we're backtracking a little because we do have time. Graph each of the linear relations to find their point of intersection. So again, they've given me two linear relations. Y equals 2x plus 4. That's my first one. And our second one, second equation they gave us, is y equals negative x plus 1. Okay. So remember, luckily for us, they've already set both of these equal to y, so that took away a lot of work. You might run into a question where, like in the last one there, it's not set equal to y. So you'll have to set it equal to y before you can start graphing anything. Okay. So remember, I'm going to keep this y equals mx plus b I'm going to rewrite it underneath both of them, just so it helps me stay organized. Oh, don't forget x. Helps me stay organized with what my slope is. Slope is m, so it's going to be 2. Here, m is negative what?
1.
Yeah, that's right. There's technically a 1 there. And here, my b is 4. And in this one, the b is just the number 1. So I have to graph 2 lines. So I'm going to bring up a graph. So we have our graph. And what we're going to do is we're going to graph each of these equations. So we'll do the first one, equation 1. We will do him in, I guess, blue or green or something like that. But as for now, we start at the y-intercept. The y-intercept for the first one is positive 4. So we go up to positive 4, plot that point. Now the slope is 2. Okay. So what does that really mean as it a rise over run?
Rise to run 1.
Yes, good. So it's really 2 over 1. So we go up to 1, 2 over 1. Up to 1, 2 over 1. Okay. And we also do the opposite, just so we can extend it. We go down 2 to the left 1. Down 2 to the left 1. Okay. So that's where we get this line. Catch up. Okay. That's going to take a bit of time. So that's roughly our line. Okay. So we've got our line here. That's for the very first equation. That's equation 1. Now we got to do equation 2 here. There we go. So that's our equation 1, our line number 1, and it extends the other way. Our line number 2 now, our m was equal to negative 1. So what does that mean as a rise over run?
Go down 1 and over positive 1.
That's right. It's technically negative 1 over positive 1. But we still got to get our y-intercept. Our y-intercept was positive 1. So that means I'm over here. And I go down 1 to the right 1. So down 1 to the right 1, down 1 to the right 1. Okay? Now if I continue that way, I'm never going to cross the line. That's why I have to know I can go the other way too. I go up 1 to the left 1, right? Opposite ideal. Up 1 to the left 1. So we get a line here. Right? I don't have to extend it too far because it looks like I've pretty much got it, even though I didn't draw a very nice line. We can tell that this is our point of intersection. Okay? I didn't draw it perfectly straight. But our point of intersection is when x is 1. So when x is 1. And when y is 2.
Isn't it negative 1?
Oh, yes. Good for you. Negative 1 and y is positive 2. So that's our point of intersection. And this was our second line we drew. Okay? So essentially it's just graphing 2 lines and finding out where they cross. For the most part, I'm pretty sure you're not going to have decimals in your points of intersection when you graph. That's when you do substitutions, when you get like fractions of answers, because it's hard to graph and see a fraction type answer.